In this lesson, we will discuss how to calculate annuity values when interest rates vary during the annuity period. When interest rates vary over the term of the annuity, we need to break up the annuity stream and calculate values at different points in time using the appropriate interest rate. Let's look at an example demonstrating how this works. In this problem, we have an annuity due paying $100 at the beginning of each period for 10 years. We're also told that the effective interest rate is 8% for the first 6 years and 7% for the last 4 years. The goal is to calculate the cumulative value at the end of the 10th year, or time 10. Let's explore one way of calculating this accumulated value. There are 10 total annuity payments. We need to figure out how to accumulate each one of them. Since 8% only applies during the first 6 years, we can only accumulate using 8% up to the end of the 6th year, or times 6. Let's consider the first 6 payments of $100, which are made at the beginning of each year 1 through 6. Note, the time 0 is the beginning of year 1, and time 5 is the beginning of year 6. These 6 payments are accumulated to time 6 using an 8% effective interest rate. So at time 6, the accumulated value of the deposit made at time 0 is 100 times 1.08 to the 6th, and the accumulated value of the deposit at time 5 is 100 times 1.08. The first bullet point shows that the sum of these first 6 accumulated values at time 6 is actually the accumulated value of an annuity due, which is equal to 100 S.6 at 8%. This is because the payments are each made at the beginning of the period, and the accumulated value is evaluated at one period after the last payment is made. As you can see, the last payment is made at time 5, but the value is calculated at time 6. And this is the classic definition of the annuity due. However, we're not done yet, since we need to calculate the value at time 10. From time 6 to time 10, we have a different effective annual interest rate. It is 7%. So all values starting at time 6 and ending at time 10 must be accumulated using a 7% interest rate. First of all, 100 S.6 at 8%, which was evaluated at time 6, must be accumulated to time 10 for another 4 periods using 7%. Or in other words, it must be multiplied by a factor of 1.07 to the 4th. This is the equation shown in the first arrow of the second bullet. The remaining 4 payments of the 10-year annuity starting at time 6 and ending at time 9 are accumulated using 7%. This, again, can be expressed as the accumulated value annuity due 100 S.4 at 7%. Therefore, the total accumulated value at time 10 is the sum of these 2 accumulated annuity dues and is equal to $1,513.59. Another way to look at this calculation is to break it up into 7 payments accumulating as annuity immediate at 8% and the last 3 payments accumulating as an annuity due at 7%. In this case, the first bullet shows the accumulated value of the first 7 payments at time 6. Here, the 7th and last payment is at time 6, and since the accumulated value is evaluated at time 6, this becomes an annuity immediate 100 S7 evaluated at 8%. We still need to accumulate the value to time 10 using 7% effective interest rate. So we will add a factor of 1.07 to the 4th to the 100 S7 as shown in the first arrow of the second bullet. The remaining 3 payments, made at time 7, 8, and 9, are accumulated to time 10 using an annuity due of 100 S.3 at 7%. Thus, our final total accumulated value at time 10 is the sum of these 2 annuity values and is equal to $1,513.59. Note that in either the first case of 2 annuity dues, S.6 plus S.4, or the second case of the annuity immediate and annuity due, S7 plus S.3, we always have 10 total payments. It's important to keep that in mind. Now, let's consider a different way to word this problem. For this problem, we will say that the first 6 deposits are invested at 8% and the last 4 at 7%. This is different than saying the 8% applies for the first 6 years and 7% for the last 4 years. In this case, the first 6 deposits will accumulate with 8% until the end of the period, or time 10, and the last 4 will accumulate at 7% until time 10. Thus, you can see that the payment at time 0 accumulates for 10 periods and is equal to 100 times 1.08 to the 10th, and the payment at time 5 accumulates for 5 years and is equal to 100 times 1.08 to the 5th. The last 4 payments are accumulated at 7% to time 10 in the same way as before. After some algebraic manipulations, we get that the accumulated value at time 10 of the first 6 payments is S.6 at 8% times 1.08 to the 4th. The accumulated value of the last 4 payments is 100 S.4 at 7%. As you can see, the main difference between this structure and the previous example structure is that the first 6 deposits are accumulated from time 6 to time 10 with an 8% interest rate rather than the 7%. Please review the 2 bullets under accumulated value to see how this is the case. In the end, the total accumulated value is $1,552.96. One additional note. You may remember that an accumulated value determined after the last payment is made, or another way to say it, S sub n valued at time n plus k, can be expressed as S sub n plus k minus S sub k, as long as the interest rate is the same for the entire period. Therefore, we can express the value of the first 6 payments at time 10 as S.10 at 8% minus S.4 at 8%. This is the equation shown in the last bullet point, and the total value is the same as before, $1,552.96.